What if dinosaurs never went extinct? Part 1. The day the sky almost fell. Take a slow breath and let everything soften for a moment. Now imagine this. It is an ordinary spring morning, 66 million years ago. There are no cities, no humans, no distant hum of traffic. Only wind moving through towering ferns, and the low call of something enormous in the distance. Above you, the sky is impossibly blue and feels endless. Then something changes. High above the atmosphere, an object appears, not a cloud and not a storm. A mountain of rock, nearly 10 kilometers wide, moving at 20 kilometers per second. That is fast enough to travel from New York to Los Angeles in just 3 minutes. This rock has drifted through space for millions of years. It was gently nudged by Jupiter and quietly guided by gravity, like a cosmic pinball on a slow collision course with Earth. In our timeline, it strikes. The impact releases energy equal to 100 million nuclear bombs. Wildfires sweep across continents, and tsunamis rise hundreds of meters high. Dust fills the atmosphere, and sunlight fades for more than a year. Temperatures begin to fall. Plants die first, then herbivores, and finally, the great predators. 75% of all life disappears, including every dinosaur larger than a house cat. That moment is recorded in stone. A thin layer of iridium-rich clay marks the boundary between the Cretaceous and the Paleogene. But tonight, we gently erase that line. Here is something most people do not realize. Asteroids do not have destiny. They have probability. If that rock had arrived a few minutes earlier or a few minutes later, it might have landed in deep ocean instead of shallow coastal water. That would mean less vaporized sulfur, less dust blocking sunlight, and far less global cooling. It might even have missed Earth entirely. And if that happened, dinosaurs would wake up the next morning shaken, but alive. Their reign would continue, and you would not be here listening to this. Let that thought settle in for a moment. If you enjoy exploring quiet, mind-bending science like this, the kind that gently reshapes how you see history, consider liking the episode and subscribing to the channel. You can also share your thoughts in the comments and tell me where in the world you are listening from. It helps these long-form ideas travel further, and I truly enjoy reading your perspectives. Now let us lower the lights a little. We are stepping into a version of history that never happened. Without extinction, the late Cretaceous continues. And this was not a collapsing dinosaur world waiting to fail. That is a myth. Dinosaurs were not fading, and they were not evolutionary mistakes. They were thriving. For 165 million years, dinosaurs dominated Earth. Let that number rest for a moment. Modern humans are only about 300,000 years old. The entire genus Homo has existed for roughly 2.5 million years. Dinosaurs ruled the planet more than 60 times longer than our entire evolutionary story. They were not temporary. They were the system. North America was divided by a warm inland sea. Antarctica held forests, and there were no permanent ice caps. Crocodiles lived near the Arctic Circle. Carbon dioxide levels were around 4 times higher than today. The world was warm, wet, and green, and it was full of life. Let us look more closely at Tyrannosaurus rex. Not the slow, tail-dragging version from old films, but the real animal. It measured 12 meters long and weighed nearly 9 tons of muscle and bone. Its teeth were the size of bananas and serrated like steak knives. It also had exceptional depth perception. With forward-facing eyes and true binocular vision, it could judge distance with remarkable precision. Imagine something the size of a bus with the visual accuracy of a hawk. That is not a scavenger. That is a calculated hunter. And it was not alone. Smaller theropods likely hunted in coordinated groups. Armored giants like Ankylosaurus defended themselves with bony plates and powerful tails. Vast herds of Triceratops moved across the landscape, and in some fossil regions they represent up to 80% of large dinosaur remains. Picture the American plains before industrialization. Now replace the bison with millions of 9-ton, 3-horned giants. That was ordinary. That was daily life. Mammals existed too, but they were small. The largest were about the size of a badger, and most were closer to mice. Why? Because dinosaurs were exceptionally efficient at being large. They had bird-like respiratory systems where air flowed in one direction, allowing highly efficient oxygen extraction. They had hollow bones, they laid eggs, and they grew quickly. In evolutionary terms, dinosaurs were optimized. Mammals were competing in a heavyweight division while wearing ankle weights. Without the asteroid, mammals likely remained small. There would be no elephants, no whales, and no primates walking upright. Just intelligent and adaptable creatures living quietly in the margins. So let us rewrite the moment. The asteroid tears through the sky, but instead of striking shallow waters near the Yucatan, it plunges into the deep Pacific. There is a massive tsunami and regional devastation. But no global winter. The dust settles within months, sunlight continues to reach the surface, and ecosystems stabilize. Dinosaurs remain dominant, and history moves forward. Now the real question begins. If dinosaurs survive, what unfolds over the next 66 million years? Do some species evolve greater intelligence? Do feathered dinosaurs fill forest canopies the way primates eventually did? Do marine reptiles take ecological roles that whales later occupied? Do giant pterosaurs continue ruling the skies? The greatest long-term challenge to dinosaurs was not the asteroid, it was climate. Not human-driven climate change, but geological climate change. The planet was gradually cooling, continents were shifting, Antarctica would eventually freeze, and grass would evolve, transforming ecosystems everywhere. Dinosaurs had mastered a greenhouse world. But could they adapt to ice? Could they thrive in open grasslands? Could they handle strong seasonal variation? These are the pressures that shape mammalian evolution. Would dinosaurs respond the same way? That is where our story moves next, because when grass appears, everything changes. For now, let the image remain. Imagine looking into the sky and seeing not an aircraft, but an animal with an 11-meter wingspan gliding overhead. Picture a world where the dominant life form is not human, and not mammal, but dinosaur. In that world, you never existed. Take one more slow breath. In part 2, we step into the world they inherited, and the quiet evolutionary arms race already unfolding. 66 million years is a long time, and we are only at the beginning, a planet without ice. 66 million years ago, Earth was warmer than today, much warmer. There were no permanent ice caps at the poles. Let that sink in. Antarctica, the frozen desert we imagine, was covered in forests, green, lush, temperate. Sea levels were about 150 to 170 meters higher than today. Entire coastlines we know simply didn't exist. Large parts of North America were underwater, split by a shallow inland sea stretching from the Gulf of Mexico to the Arctic. Imagine sailing from Texas to Canada without ever leaving warm coastal water. Carbon dioxide levels were several times higher than today. The greenhouse effect kept temperatures stable from equator to pole. This was not a harsh survivalist world. It was a garden, and in that garden dinosaurs were not struggling. They were thriving. The ecosystem at its peak. If you could stand in what we now call Montana, in a place scientists call the Hell Creek Formation, you wouldn't see isolated monsters. You'd see a functioning ecosystem, and it would feel strangely familiar. Not because it looks like our world, but because the ecological structure is the same. There are grazers. There are browsers. There are apex predators. There are scavengers. There are small omnivores living in shadows. Nature always organizes itself into roles. The species change. The system remains. And in the late Cretaceous, that system was humming. Triceratops may have been one of the most common large herbivores on Earth. Some paleontologists estimate they make up the majority of large dinosaur fossils in certain regions. Think about that. Not rare, not legendary, common, like deer, like cattle, like bison once were. That changes the mental image, doesn't it? Instead of isolated giants, imagine endless herds stretching toward the horizon, the ground trembling not from one dinosaur, but thousands. Not primitive, advanced. We often imagine dinosaurs as primitive reptiles. That image is outdated. Many theropods, the group that includes raptors and early birds, had feathers. Not decorative fluff. Functional insulation. Some had complex social behavior. Some had brains proportionally larger than expected. They were not evolutionary mistakes. They were extremely successful solutions to a long-running environmental equation. And remember, they had survived volcanic winters. They had survived shifting continents. They had survived climate fluctuations over millions of years. The asteroid wasn't correcting a failure. It interrupted a success. The sky belonged to giants. And then there were the skies. Let's talk about something that sounds like fantasy but isn't. Quetzalcoatlus, a pterosaur. Not technically a dinosaur, but a close relative, with a wingspan of about 11 meters. That's roughly the size of a small airplane. Picture standing in an open field and seeing something that wide glide silently overhead. Its bones were hollow, reinforced internally like the structure of an airplane wing. Despite its size, it may have weighed less than many adult humans. Evolution had figured out lightweight engineering long before aerospace design existed. And in our alternative timeline, these creatures don't vanish. They evolve. The sky doesn't belong exclusively to birds. It becomes a shared battlefield of air. The quiet revolution of plants. Here's something most people overlook. While we focus on dinosaurs, plants were quietly changing the game. Flowering plants, angiosperms, were spreading rapidly during the late Cretaceous. And flowering plants are sneaky geniuses. They produce fruit. Fruit is basically a bribe. Eat this sweet thing, and carry my seeds somewhere else. It's one of evolution's most effective marketing strategies. Without extinction, flowering plants continue expanding. And that means new ecological opportunities. Fruit-eating animals gain advantages. Climbing becomes useful. Grasping hands matter. Binocular vision matters. Suddenly, the canopy becomes a new frontier. In our timeline, primates evolved in these environments. But in the dinosaur timeline, small feathered theropods were already positioned to exploit it. Lightweight, agile, grasping claws, sharp vision. You can almost see where this is going. But hold that thought. We're not at intelligence yet. We're at environment. The mammals stay in the shadows. Let's revisit mammals for a moment. In our world, mammals exploded into dominance after the extinction. But in this timeline, nothing clears the stage. Dinosaurs remain large and dominant, and mammals continue doing what they had been doing for over 150 million years. Being small, being clever, being nocturnal. Here's something fascinating. Recent studies suggest early mammals weren't primarily suppressed by dinosaurs. They were competing with other mammals. The Mesozoic had many mammal groups that are now extinct. It wasn't a simple dinosaurs kept mammals down story. It was a crowded ecosystem. Without extinction, that crowding continues. Mammals likely remain marginal players. No elephants, no whales, no primates expanding into large-bodied dominance. Just agile little survivors navigating niches dinosaurs don't care about. A stable but temporary paradise. Now here's the quiet tension in this story. The world looks stable, warm, green, productive, but beneath the surface, change is coming. Continents are drifting. India is moving north toward Asia. Ocean currents are subtly shifting. Mountains are beginning to rise. And over millions of years, these geological shifts will slowly pull carbon dioxide out of the atmosphere, cooling the planet. Not suddenly, not dramatically, but steadily. And dinosaurs have never lived in a truly cold world. They've never faced permanent polar ice. They've never dealt with vast seasonal extremes. They mastered the greenhouse Earth. But Earth is about to try something different. And that, not the asteroid, may be their greatest challenge. So here we are, 10 million years after the asteroid that never struck. Dinosaurs still dominate. Forests still stretch from pole to pole. Pterosaurs still rule the sky. Marine reptiles still control the oceans. Mammals remain small. Everything feels eternal. But evolution never sleeps. And the next chapter of this planet's story won't be written in fire from space. It will be written in temperature, in slow cooling, in new plants spreading across open land, in grass. And when grass arrives, the rules of survival will change completely. In part 3, we'll explore why mammals stayed small for so long, and why dinosaurs were physiologically built to win the size game. And trust me, once you understand their respiratory system, you'll never look at a bird the same way again. If this world feels vivid in your mind right now, good. That means we're building it properly. We're only 10 million years into a 66 million year alternate history, and the real transformation hasn't even started yet. Part 3. Built to Win, The Secret Physiology of Dinosaurs. Let's get something straight. Dinosaurs didn't dominate Earth for over 160 million years by accident. They weren't lucky. They weren't just big. They were engineered, by evolution, to be frighteningly efficient biological machines. And today we're pulling back the curtain on the part most people never think about, their breathing system. Because once you understand how dinosaurs breathed, you'll understand why mammals were stuck in the evolutionary slow lane for so long. The mammal way, in and out. Let's start with us. Mammals breathe using what's called a tidal system. Air goes in, air goes out, using the same tubes. Think of it like a cul-de-sac. Air enters your lungs, reaches tiny sacs called alveoli, oxygen moves into your blood, and then you push that same air back out the way it came. It works fine, but it has a built-in inefficiency. When you inhale, fresh oxygen mixes with leftover air already in your lungs. You never get pure, fresh oxygen flowing across your gas exchange surface. It's like trying to refill a glass without emptying the old water first. Efficient? Sure. Optimized? Not exactly. The dinosaur way. One-way flow. Now here's where it gets wild. Evidence from fossilized bones and comparisons with modern birds strongly suggests that many dinosaurs had a unidirectional airflow system. Air flowed through their lungs in one direction. Not in and out the same way. In one direction. Constantly. That means fresh oxygen-rich air was always moving across the respiratory surface, even while exhaling. Let me say that again because it sounds subtle, but it's huge. Even while breathing out, oxygen was still being absorbed efficiently. Imagine running on a treadmill while someone keeps handing you fresh oxygen continuously. That's a performance upgrade. Modern birds use this system, and birds are the living descendants of theropod dinosaurs. So when you see a pigeon casually flying for hours, you're looking at respiratory technology perfected in the age of Tyrannosaurus. Air sacs, built-in oxygen boosters. Dinosaurs didn't just have lungs, meaning they likely had air sacs, balloon-like extensions that moved air through their bodies. These air sacs increased oxygen efficiency, reduced body weight, helped regulate temperature. They even extended into hollow bones. Yes, some dinosaur bones were literally filled with air spaces connected to their respiratory system. That means their skeleton wasn't just support, it was ventilation. Picture a skyscraper with built-in air ducts running through every beam. That's what evolution did. And that's part of why massive sauropods, animals weighing as much as modern whales, could survive on land. Their respiratory system scaled. Mammalian lungs? Not so easily scalable. There's a reason elephants don't get much bigger. Physics and oxygen delivery impose limits. Dinosaurs were playing with a different toolkit. Oxygen and intelligence. Now let's connect this to something people care deeply about. Brain power. Brains are oxygen hogs. Ian, your brain uses about 20% of your body's oxygen, even though it's only about 2% of your body weight. Efficient oxygen delivery allows for higher metabolic output. Higher metabolic output supports endothermy, warm-bloodedness, sustained activity, larger brains. For a long time, scientists assumed dinosaurs were sluggish, cold-blooded reptiles. That picture has changed dramatically. Bone growth rates, isotopic analysis, and predator-prey ratios suggest many dinosaurs had elevated metabolisms, possibly fully endothermic. In other words, they weren't giant lizards sunbathing. They were active, fast-moving animals with internal temperature regulation, closer to birds and mammals. And with that respiratory system, they had serious biological horsepower. So why were mammals small? Here's the uncomfortable truth for Team Mammal. In the Mesozoic world, mammals were outcompeted in large-bodied niches. Dinosaurs had superior respiratory efficiency, lightweight skeletal adaptations, egg-based reproduction, no long pregnancies, rapid growth rates, Meanwhile, early mammals invested heavily in gestation, produced fewer offspring, lacked air sac systems, had more constrained body plans. It's not that mammals were inferior. They were just playing a different evolutionary strategy. Small, nocturnal, flexible. They survived in the margins. And sometimes surviving in the margins is smarter than fighting giants. But without the asteroid, there's no empty throne, no ecological vacuum. No opportunity for mammals to suddenly become rhinos, giraffes, whales, and primates. Dinosaurs don't just stay, they adapt. Cooling Earth, rising challenge. Now here's where the long game kicks in. As we mentioned in part 2, Earth begins a slow cooling trend over millions of years. And here's the twist. A high-efficiency respiratory system is incredibly useful in active warm climates. But cold climates introduce new pressures. Insulation matters. Seasonal food shortages matter. Migration patterns matter, and this is where feathers become a critical evolutionary asset. Feathered dinosaurs aren't just flashy. They're insulated. They can regulate heat. And in a cooling world, insulation is everything. So who thrives? Likely, smaller, feathered, adaptable theropods. Large tropical giants may struggle as ecosystems shift. Open grasslands begin expanding. Forests retreat in some regions. New plant types appear. New diets emerge. Evolution doesn't reward past champions. It rewards present adaptability. The hidden contender. And here's the fascinating possibility. Among theropods were small, agile, feathered predators with grasping forelimbs and forward-facing eyes. Some had relatively high encephalization quotients, meaning their brains were larger relative to body size than many other dinosaurs. Not human level. Not even close. But trending upward. Given 66 more million years without extinction, what happens? Does one lineage slowly increase cognitive capacity? Does problem solving become advantageous in more complex ecosystems? Does tool use ever appear? We don't know. But evolution has produced intelligence multiple times independently, in mammals, birds, and even cephalopods. Intelligence is not a miracle. It's an adaptation. And adaptations appear when they're useful. Let's pause here, because we've just dismantled a myth. Dinosaurs weren't evolutionary dead ends waiting to be replaced. They were highly optimized organisms with respiratory systems arguably more efficient than ours. They had the infrastructure for endurance, for size, for sustained activity, and potentially for cognitive expansion. So in this alternate Earth, as the climate cools and ecosystems reorganize, the question is no longer, would dinosaurs survive? The question becomes, which dinosaurs evolve next? In part 4, we're stepping into the oceans, because while we've been focused on land, there were monsters in the sea, and without extinction, the oceans might become the most terrifying arena of all. Part 4. The ocean that never emptied. Let's leave the forest for a moment. Close your eyes and step into the sea, because while dinosaurs ruled the land, the oceans were hosting a completely different arms race. And in our timeline, the asteroid didn't just wipe out land dinosaurs, it devastated marine ecosystems. Plankton collapsed, food chains shattered, entire lineages disappeared almost overnight. But in this alternate Earth, the oceans never reset. They kept evolving. And that might be even more dramatic than what happened on land, a sea full of predators. When we think of ocean giants today, we imagine whales and great white sharks. But 66 million years ago, those animals didn't exist. Instead, the oceans were dominated by marine reptiles. Let's meet a few. Mosasaur. Picture a Komodo dragon, stretched to the length of a bus, with a shark-like tail and double-hinged jaws. Some species grew over 15 meters long. They weren't dinosaurs technically, they were marine lizards, but they were apex predators. Then there were plesiosaurs, long necks, small heads, 4 powerful flippers, almost like underwater dragons built for stealth. And ichthyosaurs, though declining by the late Cretaceous, resembled massive, high-speed dolphins with reptilian ancestry. The oceans were not gentle. They were competitive, fast, violent, and incredibly productive. The food web that held it all together. Here's something easy to overlook. Big predators only exist when the bottom of the food chain is stable. Tiny plankton, microscopic organisms drifting near the surface, form the foundation of marine ecosystems. They capture sunlight. Small fish eat them. Medium predators eat those fish. And eventually, something with teeth the size of your arm eats everything else. In our timeline, the asteroid impact disrupted photosynthesis globally. Dust and aerosols blocked sunlight. Plankton populations crashed. And when plankton crash, everything above them collapses like dominoes. But in our no-asteroid world, plankton keep photosynthesizing. Fish populations remain stable. Marine reptiles keep hunting. There's no ecological freefall, which means whales never get their opening. Because here's the twist. Whales evolved from land mammals that returned to the ocean after the extinction. No extinction. No empty seas. No evolutionary invitation. No whales. No dolphins. Let that sink in for a second. In this alternate Earth, there are no whales singing in the deep. No dolphins riding waves. No orcas coordinating hunts. Marine mammals likely never evolve into dominant ocean predators. Because marine reptiles are already there, it's like trying to open a coffee shop in a city block already packed with legendary cafes. There's no market gap, so mammals stay coastal at best. Maybe small semi-aquatic forms survive, otter-like creatures perhaps, but nothing approaching a blue whale, and that changes the entire soundscape of the planet. The oceans would be quieter in one way, but far more reptilian. Evolution never stops competing. Now here's where it gets interesting. Marine reptiles were powerful, but they weren't invincible. Sharks were already well established long before dinosaurs. And sharks are evolutionary minimalists. Cartilage skeletons, replaceable teeth, efficient reproduction. They survived multiple mass extinctions before. In our timeline, sharks thrived after marine reptiles vanished. In the alternate timeline, sharks and marine reptiles continue competing. That competition would drive innovation. Faster swimmers, smarter hunters, better camouflage, perhaps even more complex social hunting behavior in some lineages, because predator-prey relationships are evolutionary pressure cookers. They push speed, they push sensory development, they push brain capacity, and when environments become more complex, cognition becomes valuable. Intelligence in the sea? We often assume intelligence is a mammal story, but that's bias. Modern birds solve puzzles, octopuses use tools. Dolphins cooperate in coordinated strategies. Intelligence evolves when social interaction is complex, hunting requires strategy, environments demand flexibility. Now imagine a lineage of marine reptiles, already dominant, already long-lived, evolving in stable oceans for another 60 million years. Could one branch develop higher social complexity, longer parental care, cooperative hunting? It's not guaranteed, but it's not impossible either. Especially in open water predators where communication matters. We might end up with something like reptilian analogs to dolphins. Scaled, streamlined, possibly social. That's a strange mental image, but evolution isn't concerned with our comfort. It follows opportunity. The cooling oceans. Remember the slow cooling trend we discussed earlier? It affects oceans too. As global temperatures gradually decline, ocean circulation patterns change. Cold water sinks, warm water rises. Nutrient mixing shifts. Upwelling zones expand in some areas. That can actually increase marine productivity in certain regions. More nutrients, more plankton, more fish. Which means more pressure on apex predators to specialize. Large marine reptiles adapted to warm tropical seas may struggle in cooler waters. But smaller, more metabolically flexible species might thrive. Insulation becomes an advantage. Faster metabolism becomes valuable, and again, the evolutionary race tightens. A planet with two kingdoms. So by this point in our alternate timeline, Earth is divided into two great arenas. Land, dominated by feathered and non-feathered dinosaurs adapting to cooling climates. Sea, ruled by marine reptiles locked in evolutionary chess matches with sharks and fast-moving fish. And mammals? Still waiting, still surviving in corners, still adaptable, but not yet central. And here's something quietly profound. In our world, sea mammals became dominant both on land and in sea. In this alternate world, reptiles retain their stronghold in both domains. That changes the entire trajectory of large-brained life, because intelligence doesn't emerge in isolation. It emerges in ecosystems, in social structures, in survival challenges. And right now, in this version of Earth, the most intense evolutionary innovation might be happening underwater. Let's zoom out for a second. We've built a world where dinosaurs dominate land, marine reptiles dominate oceans, mammals remain minor players, the climate slowly cools, ecosystems grow more complex. No asteroid, no global reset, just evolution, stretching forward uninterrupted. But stability is deceptive, because something subtle is brewing. Grasslands are spreading, forests are fragmenting, open plains are expanding, and open plains change everything. In Part 5, we're stepping into a world of windswept landscapes, where speed becomes king, herds grow massive, and survival demands new strategies. And in wide open spaces, visibility changes, predator tactics change, and maybe, just maybe, the path toward higher intelligence becomes clearer. The world is shifting, slowly, relentlessly, and the dinosaurs don't even know it yet. Part 5. When the forests break. The age of grass and speed. Something quiet is happening. No explosions, no asteroids, no sudden apocalypse, just wind. Wind moving across newly opened land. Because the forests are thinning. Over millions of years, as Earth slowly cools and continents continue to drift, rainfall patterns shift. Some dense tropical forests retreat. Seasonal climates become more common. And into those open spaces steps one of the most underestimated evolutionary forces on Earth: grass. Now that might sound underwhelming. Grass? Really? But let me tell you something. Grass reshaped our world more dramatically than almost any predator ever did. And in our alternate dinosaur timeline, it reshapes theirs too. The quiet power of grass is not just short green stuff under your feet. It's an evolutionary weapon. Unlike trees, grass grows from the base, not the tip. So when something eats it, it grows back, stronger, faster. It also contains silica, microscopic mineral particles that act like sandpaper. Every bite wears down teeth. That means any animal wanting to specialize in eating grass needs tougher teeth, or constantly replacing teeth, or entirely new chewing strategies. In our world, mammals evolved high crowned teeth and complex jaw mechanics to handle this. But in the dinosaur world, the question becomes, which dinosaurs adapt to the grass revolution? Because once grasslands expand, everything changes. Visibility increases, speed becomes survival, herd behavior becomes essential, and stamina matters more than ambush. The rise of the runners. In dense forests, a predator can rely on surprise. In open plains, there's nowhere to hide. Now imagine vast dinosaur herds moving across wide savannas stretching hundreds of kilometers. Herding behavior likely becomes more sophisticated. Group coordination improves. Visual communication matters. Warning signals matter. Predators must either become faster or smarter. Now let's talk about ornithopods, duck-billed dinosaurs like hadrosaurs. They already had complex dental batteries, hundreds of tightly packed teeth designed for grinding plant material, perfect for processing tough vegetation. In a grass-dominated world, they may diversify dramatically. Smaller, faster species emerge, longer legs, more endurance. Perhaps migration patterns similar to modern wildebeest. Picture that. 1 million feathered or partially feathered herbivorous dinosaurs thundering across a golden plain. And behind them, predators built not just for power, but for pursuit. Speed becomes currency. Open landscapes reward speed. This is where theropods, already agile and bipedal, gain an advantage. Longer limbs, lighter builds, better balance. Some lineages may evolve into specialized pursuit hunters. Think of something like a cross between a raptor and a cheetah. High endurance, coordinated pack behavior. Because here's the thing about open plains. It's not just about outrunning one predator. It's about outlasting them. Endurance hunting becomes viable, and endurance requires efficient respiration. Remember the unidirectional airflow system we discussed in Part 3? That respiratory advantage now pays massive dividends. Dinosaurs weren't just strong, they were built for sustained oxygen delivery. On the plains, that's gold. Eyes forward open to rain also changes sensory demands. In forests, smell and sound dominate. In plains, vision rules. Forward-facing eyes allow better depth perception. Depth perception helps with precise strikes. Precise strikes conserve energy. Energy conservation increases survival odds. Over millions of years, subtle changes in skull structure could improve binocular vision in some predatory lineages. Now we're stacking traits: high oxygen efficiency, endurance capability, advanced visual processing, social coordination. You see where this is going, right? We're not saying intelligence suddenly appears, but the ingredients for increased cognitive complexity are quietly accumulating. Because hunting in open terrain, especially in coordinated groups, requires communication, timing, strategy, and maybe even role differentiation. The social brain. There's something called the social brain hypothesis. It suggests that intelligence evolves primarily to handle complex social relationships, not just to solve physical problems. Primates didn't get big brains just to crack nuts. They got big brains to manage alliances, competition, cooperation, deception. Now imagine large herds of herbivorous dinosaurs navigating migration routes, coordinating defense, responding to predators. And imagine packs of theropods adapting cooperative hunting strategies. Social complexity increases. And when social complexity increases, brains tend to follow, not overnight, not magically, but incrementally. Neural circuits that improve coordination get selected. Memory improves. Communication signals diversify, and somewhere in that evolutionary arms race, a lineage might begin trending toward greater cognitive flexibility. The world becomes seasonal. As cooling continues, seasons grow more pronounced in many regions. Winter scarcity becomes a real challenge. Migration becomes more critical. Food storage strategies, even simple caching behaviors, might emerge in some small omnivorous species. Feathers provide insulation. Metabolic control becomes crucial. And here's a fascinating twist. Smaller body sizes often adapt better to environmental variability. So while giant sauropods may decline in colder climates, mid-sized feathered theropods may flourish, agile, warm-blooded, social, visually oriented, and increasingly adaptable. Mammals still watching. And mammals? Still here? Still clever? Still opportunistic? In grassland ecosystems, burrowing mammals may expand. Grass roots stabilize soil. Burrows become safer. Small mammalian omnivores could thrive beneath the feet of giants. But without large body niches opening up, they remain background players. It's like being brilliant in a room where no one hands you the microphone. The opportunity just hasn't arrived. Let's step back. We now have a planet where grasslands stretch across continents. Massive dinosaur herds migrate seasonally. Pack hunting theropods evolve endurance strategies. Social complexity increases. Visual processing becomes critical. Climate variability rewards adaptability. This is no longer the lush, slow-moving jungle world of early dinosaurs. This is dynamic, competitive, demanding. And in demanding environments, evolution sharpens its tools. We're about 30 to 40 million years past the asteroid that never came. The dinosaurs are no longer just survivors of a warm greenhouse Earth. They are adapting to a cooler, more variable, more open world. And somewhere in those sweeping plains, among smaller, feathered predators with grasping forelimbs, a subtle shift may be underway. Because the next step isn't just speed. It isn't just endurance. It isn't just social complexity. It's manipulation. Hands, claws, fine motor control. In Part 6, we're going to explore something that sounds almost like science fiction. Could a dinosaur lineage ever develop tool use? And if it did, what would a reptilian intelligence look like? The wind is still moving across the grass. The herds are still migrating, but evolution is starting to experiment. Part 6. Claws, curiosity, and the first tools. Let's slow this down. We've built a world of open plains. We've built herds, migration, endurance hunting. We've built social complexity. Now we ask the dangerous question, what if one lineage of dinosaurs starts doing something new? Not faster, not bigger, smarter. But before we go wild with imagination, let's ground ourselves. Tool use is not magic. It's not uniquely human. It's not even uniquely mammalian. Crows bend wires into hooks. Octopuses carry coconut shells for shelter. Chimpanzees sharpen sticks to hunt bush babies. Tool use appears when three conditions align: manipulative anatomy, cognitive flexibility, environmental pressure. So let's test dinosaurs against that checklist. Step 1. The hands. Most dinosaurs didn't have hands like ours, but some came surprisingly close. Theropods, the same lineage that eventually gave rise to birds, had grasping forelimbs. 3 fingers in many species. Clawed, mobile. Not delicate like primate hands, but not useless either. Some smaller theropods had semi-opposable digits. Not true thumbs, but capable of gripping and holding objects against the palm. Now imagine millions of years of gradual refinement. Claws becoming less curved and more dexterous. Digits becoming slightly more independent. Muscle attachments growing more precise. Evolution doesn't leap, it nudges. And tiny improvements in object manipulation, holding prey differently, stabilizing food, digging, can accumulate over vast time. Step 2. The brain. We know some theropods had relatively high encephalization quotients for reptiles. Troodontids, for example, had brain-to-body ratios approaching those of modern birds. Not genius level, but flexible. Bird brains today are far more complex than we once thought. They have densely packed neurons, especially in regions related to problem solving, and birds descended directly from these theropods. So the neurological foundation was already there. Now layer on increasing social complexity from pack hunting and migration. Add seasonal challenges requiring memory. Add competition from other intelligent predators. Neural circuitry that improves planning, coordination, and learning gets reinforced. Over tens of millions of years, eat incremental growth compounds. Step 3. Environmental pressure. Open plains create scarcity during winter. Forests fragment. Food becomes less predictable in some regions, and unpredictability is fuel for innovation. When food is easy, you don't invent. When food is scarce, you experiment. Maybe a small omnivorous theropod starts cracking hard-shelled prey against rocks. Maybe it uses sticks to probe into burrows for mammalian rodents. Maybe it drags carcasses into sheltered areas to guard them from competitors. At first, these behaviors are simple, instinctive, accidental. But individuals who learn faster survive longer, and learning is a form of evolution inside a lifetime. If offspring observe and imitate successful strategies, culture begins. Not human culture, but behavioral traditions. What about fire? Let's address the dramatic idea. Fire is transformative for intelligence. But could dinosaurs ever control it? Almost certainly not in the early stages. Fire requires fine motor control, abstract planning, understanding cause and effect, safe storage and maintenance. Even early humans struggled with consistent fire control. For a dinosaur lineage to reach that level, millions more years of cognitive expansion would be required. But here's something subtle. They wouldn't need fire immediately. Tool use alone changes ecological dynamics. A sharpened stick increases hunting efficiency. A stone used to crack bone increases caloric intake. More calories support larger brains. Larger brains enable better tools. It's a feedback loop. A different kind of intelligence. Now here's where it gets fascinating. Even if a dinosaur lineage evolved advanced cognition, it would not think like us. Mammalian brains emphasize emotional bonding and social hierarchy, shaped by live birth and extended parental care. Reptilian and avian brains are structured differently. Birds, for example, show intelligence through pattern recognition, spatial memory, and vocal communication. A reptilian-derived intelligence might be highly visual, extremely spatially aware, skilled at coordinated movement, less emotionally expressive, at least in mammalian terms. Imagine a species that communicates through body posture, feather displays, subtle vocal clicks. Not loud language, not words at first, but signals. then symbolic sounds, then perhaps structured communication systems. Language doesn't require lips. It requires brains capable of mapping sound to meaning. And birds already demonstrate complex vocal learning. The Plains Laboratory picture this. About 40 to 50 million years after the asteroid that never was, grasslands dominate large continents. Mid-sized feathered theropods roam in structured groups. One lineage becomes particularly adaptable. Not the largest, not the fastest, but the most flexible. They hunt cooperatively, they scavenge opportunistically, they experiment. One individual drops a rock onto a nest of armored prey and discovers a shortcut. Another learns to wedge a stick into a burrow to flush out rodents. These are small acts. But small acts, repeated over millions of years, become evolutionary milestones. And the mammals? Here's the bittersweet twist. In this world, mammals may never get their shot at primate-level intelligence. They remain clever, adaptive. Perhaps some become highly specialized grazers or burrowers, but without the extinction-clearing megafaunal niches, they stay in supporting roles. It's a strange reversal. In our world, mammals rose because reptiles fell. In this world, reptiles never fall, so mammals never rise. History hinges on catastrophe. The long horizon. We are now imagining a planet perhaps 60 million years beyond the late Cretaceous. Dinosaurs never went extinct. They adapted. The climate cooled gradually, grass reshaped ecosystems, social complexity increased, tool use emerged in rudimentary forms, intelligence began trending upward in at least one lineage, not humans, not primates, but something else, feathered, clawed, forward-eyed, standing upright, watching the horizon. And here's the most humbling thought of all. In this alternate Earth, there may be no cities, no satellites, no telescopes scanning the stars. Because intelligence does not guarantee technology, it only opens the door. Whether that door leads to civilization is another story entirely. In Part 7, we're going to confront the biggest question yet. If intelligent dinosaurs emerged, would they dominate the planet the way we did? Or would they choose a completely different path? Because evolution creates minds, but environment shapes ambition. Part 7. Minds without cities. Let's imagine something bold. A upright theropod standing on an open plain. Forward-facing eyes scanning the horizon. Clawed hands capable of gripping. A brain larger, proportionally, than its ancestors. Social. Cooperative. Observant. It uses simple tools. It learns from others. It remembers migration routes. It communicates with structured sounds and visual signals. Now here's the real question. Does that inevitably lead to cities? To metal? To rockets? Or is that assumption uniquely human? Intelligence is not destiny. We tend to think intelligence equals technology, but that's a very specific kind of intelligence. Human intelligence is deeply shaped by opposable thumbs, long childhood development, fire control, high-calorie diets, complex vocal language. Take away one of those pieces, and history shifts. Now imagine our dinosaur lineage again. Yes, they can grip, but not like primates. Yes, they are social, but maybe not bonded through live birth and extended parental care in the same way mammals are. Yes, they communicate, but perhaps more through posture, feather display, subtle tonal sounds. Their brains might prioritize spatial memory, visual processing, coordinated movement, environmental awareness, less focus on abstract symbolic systems, more focus on real-time adaptation. They may become incredibly smart hunters, brilliant navigators, masterful social strategists, but not necessarily builders of skyscrapers. The fire barrier. Let's talk about the biggest technological hurdle, fire. Fire unlocks. Cooking, more calories. Metalworking. Ceramics. Light at night. Protection. Humans didn't just discover fire. We learned to control it, maintain it, transport it, protect it. That requires fine motor control, planning, and social structure. A theropod with claws, even dexterous ones, may struggle with delicate fire maintenance. And remember, evolution doesn't aim for civilization. It rewards survival and reproduction. If tool use is enough to maintain dominance in ecosystems, there's no pressure to go further. You don't invent metallurgy if sharpened sticks already work. A different ecological strategy. Here's something fascinating. If dinosaurs remain dominant herbivores and predators, ecosystems stay reptile-driven. Mammals never overrun landscapes with grazing megafauna like bison or antelope. Whales never dominate oceans. Primates never colonize forests the way they did. The world remains largely balanced between reptilian megafauna and evolving avian descendants. In such a world, intelligence might integrate into ecosystems rather than reshape them. Imagine intelligent theropods acting as apex regulators, not domesticating animals, not clearing forests, but subtly manipulating environments, driving herds strategically, controlling territories through signaling, managing access to water sources. More like ecological chess players than industrial engineers. They might dominate behaviorally, not technologically. No agricultural revolution? Human civilization accelerated when we began farming. Agriculture created food surplus. Surplus created specialization. Specialization created cities. But would intelligent dinosaurs farm? Consider their diet. If they are omnivorous or carnivorous theropods, agriculture may not offer immediate advantage. Hunting already works. Scavenging works. Seasonal migration works. Also, agriculture requires seed selection, land clearing, long-term planning, food storage infrastructure that demands both cognitive abstraction and anatomical precision. Possible? Maybe. Inevitable? Not at all. They might remain advanced hunter-gatherers indefinitely. And here's the twist. That could be stable for millions of years. Communication without writing. Humans developed writing to preserve knowledge across generations. But birds today already show advanced vocal learning. Imagine a dinosaur lineage with complex tonal communication, memory spanning decades. Cultural traditions passed through imitation. They could transmit knowledge orally and behaviorally. Migration routes memorized across generations. Hunting techniques refined over centuries. Tool use traditions maintained without written language. Crows already passed down tool techniques socially. Scale that up over 50 million years. You might get rich cultural ecosystems without a single carved symbol. A planet without industry. Now let's fast forward further, another 10 million years. The climate continues to fluctuate, ice caps may form intermittently, sea levels shift, grasslands expand and contract, intelligent theropods adapt. They may spread across continents. But would they ever alter atmospheric chemistry the way humans did? Unlikely. Industrialization requires mining, smelting, combustion engines, fossil fuel extraction. That entire chain requires not just intelligence, but cumulative technological acceleration. If their evolutionary path never prioritizes delicate manipulation and abstract engineering, they may never trigger runaway industry. Which means no massive carbon spikes, no plastic oceans, no satellites orbiting Earth. Just a planet dominated by biologically integrated intelligence. And still, mammals. Wait all this time? Mammals persist in small ecological niches. Burrowers, climbers, coastal swimmers. Perhaps some develop impressive intelligence within limits, like raccoon-level cleverness. But without large body opportunities opening up, they never become global dominators. The throne remains reptilian. It's strange to think. Our existence may depend less on our brilliance, and more on a rock from space. The bigger question, so here we stand in this alternate Earth. Dinosaurs never went extinct. They adapted. Some evolved increasing intelligence. E-tool use emerged in primitive forms. Social complexity expanded, but no guarantee of cities, no certainty of technology. And here's the philosophical twist. Maybe intelligence does not always aim for conquest. Maybe human-style domination is not the default. Maybe it's an anomaly. In this world, intelligence might mean better ecological balance, long-term stability, integration rather than transformation. And if that's true, then perhaps the asteroid didn't just erase dinosaurs. It redirected the entire style of planetary intelligence. In Part 8, we're going to explore something even deeper. If intelligent dinosaurs emerged, would humans ever evolve at all? Or would our lineage quietly disappear before it even begins? Because evolution has limited space, and only so many species can climb to the top at once. Part 8. Would humans ever exist? Let's be honest. This is the question that's been quietly sitting in the back of your mind. If dinosaurs never went extinct, would we? Would there ever be primates swinging through trees? Would there ever be apes standing upright? Would there ever be humans staring at the stars wondering about dinosaurs? Or would our entire lineage vanish before it even began? Take a slow breath, because the answer is both simple and unsettling. Probably not. The fragile opportunity. In our real timeline, mammals didn't suddenly become dominant because they were better. They became dominant because the competition disappeared. The asteroid impact wiped out non-avian dinosaurs, large marine reptiles, many plant groups, entire food chains. It was catastrophic. But catastrophe creates vacancies. And evolution hates vacancies. When megafauna vanished, ecosystems were left with open niches. Large herbivore niche, large predator niche, tree-dwelling omnivore niche, aquatic apex predator niche. Mammals expanded into all of them, rapidly. Within a few million years, they diversified explosively, but without that extinction, those niches were already occupied, fully and efficiently. Primates need space. Primates evolved as small, tree-dwelling mammals. They benefited from flowering plant expansion, fruit availability, reduced reptilian megafauna pressure. If intelligent or semi-intelligent theropods continued dominating forests and plains, primates might still evolve in small numbers. But they'd face constant pressure. Large arboreal dinosaurs or bird-like descendants could compete for fruit. Ground predators would remain abundant. Social mammals attempting to grow larger would face immediate ecological resistance. Evolution isn't about potential, it's about opportunity. And opportunity is limited. The ape bottleneck. Even in our own timeline, human evolution was anything but guaranteed. For millions of years, early primates stayed small. Apes didn't appear until around 20 to 25 million years ago. Bipedal hominins, about 6 to 7 million years ago. Modern Homo sapiens, roughly 300,000 years ago. That's an incredibly narrow window. Remove the initial extinction event, and that entire cascade may never initiate. No extinction leads to no mammalian radiation, leads to no ape diversification, leads to no hominin branch. It's like removing the first domino. Nothing falls. Evolution is not inevitable. Here's something people struggle with. Evolution does not aim toward humans. There's no ladder, no destiny, no cosmic goal. Humans are one branch among millions. If conditions shift even slightly, that branch never forms. Imagine rewinding Earth's history like a movie. Start again from 66 million years ago, remove the asteroid, let climate shift gradually, let dinosaurs adapt, let ecosystems remain reptile dominant. Run that simulation 1,000 times. In how many versions do primates become dominant tool-using, fire-controlling, language-developing beings? Probably close to 0. Not because it's impossible, but because it requires an extremely specific sequence of events. The dinosaur ceiling. Now here's the twist. Even if intelligent dinosaurs evolve, they occupy cognitive space. They become the top adaptive strategists. They regulate ecosystems. They shape predator-prey dynamics. And once a lineage occupies the top adaptive tier, it's harder for another lineage to displace it. It's like trying to invent a better smartphone in a world where one company already dominates every market niche flawlessly. The barrier to entry is enormous. Mammals might remain clever, but they would likely stay peripheral, burrowing, scavenging, climbing in shadows, never rising to planetary dominance. No humans, no civilization. Without humans, there is no industrial revolution, agriculture, writing, astronomy, philosophy, global warming. The planet remains biologically shaped, not industrially reshaped. Forests expand and retreat naturally. Atmospheric CO2 fluctuates through geological cycles, not combustion engines. Oceans acidify and recover through volcanic and tectonic processes, not plastic pollution. It's a different Earth. Wild, ancient, possibly intelligent in places, but not human. The existential twist. Now pause here, because this realization is heavy. Our entire existence may depend on a random space rock, every language spoken, every city built, every song written, every scientific discovery, every podcast episode you're listening to right now. All of it traces back to an extinction event 66 million years ago. Without it, silence, or at least a different voice. Maybe a scaled, feathered mind staring at the stars instead. Could humans emerge later? Let's entertain one more possibility. Could mammals eventually evolve intelligence much later? Say 100 million years from now? Even with dinosaurs present? Theoretically, maybe. But the evolutionary landscape would be crowded. If intelligent dinosaurs continue adapting, innovating behaviorally, and occupying top niches, mammals would remain under intense pressure. Large brain development requires high caloric intake, extended parental care, stable social structures, reduced predation. Without ecological breathing room, those conditions rarely align. So the most likely answer is no humans. Not eventually, not delayed, just absent. A planet that never knows us? Imagine Earth today in that alternate timeline. It's 2026 in our calendar. But there are no calendars, no satellites, no telescopes, no cities glowing at night. Grasslands still stretch across continents. Feathered theropods migrate in coordinated groups. Marine reptiles patrol productive oceans. Perhaps somewhere, an intelligent dinosaur lineage communicates in complex vocal patterns. Perhaps they use simple tools. Perhaps they observe the stars without ever naming them. The universe exists, but it is not interpreted through human language. And that's the humbling part. The cosmos doesn't need us. We happened. Because extinction happened. We've now crossed a major threshold in our journey. Dinosaurs never went extinct. They adapted. Intelligence may have emerged in different forms. But humans? Almost certainly not. In Part 9, we're going to go even deeper. If intelligent dinosaurs evolved, what would their societies actually look like? Would they form tribes, territories, hierarchies? Would they wage war? Or would they evolve beyond it? Because intelligence shapes ecosystems, but social behavior shapes destiny. Part 9, Tribes of Feather and Scale. We've crossed the evolutionary threshold. In this alternate Earth, dinosaurs never went extinct. One lineage may have developed advanced cognition. Tool use exists in primitive forms. Communication is structured. Social complexity has deepened. Now we face the most human question of all. If intelligent dinosaurs evolved, what would their societies look like? And here's the key idea. Society is not just intelligence, it's emotion, it's reproduction strategy, it's territory, it's cooperation under pressure, and dinosaur biology changes all of it. Egg layers, not live birth. Let's start with reproduction. Most dinosaurs laid eggs. Even if some evolved more complex nesting strategies, they wouldn't have mammalian pregnancy. Humans form intense parental bonds partly because of long gestation and helpless newborns. 9 months inside the body, years of dependency after birth. That investment shapes our psychology. Now imagine a species that lays eggs in guarded nests. Parental care could still exist. Many birds today are devoted parents. But the emotional structure may differ. Instead of small family units like humans, they might organize into communal nesting grounds. Multiple adults guarding clusters of eggs, shared responsibility, shared vigilance. Social bonds could center around territory and group survival rather than nuclear families. That changes the emotional architecture of society, hierarchies of motion and display. Dinosaurs, especially feathered theropods, likely relied heavily on visual signaling. Feather displays, posture, coloration, movement, Even modern birds establish dominance and attract mates through elaborate display rituals. Now scale that up to intelligent theropods. Leadership might not be based purely on physical strength. It might involve complex display behaviors, vocal skill, strategic intelligence, memory of migration routes, success in coordinating hunts. Hierarchy could be fluid, shifting seasonally depending on resources. Less about rigid kingship, more about dynamic leadership. The smartest hunt coordinator might lead during migration. The strongest defender might lead during territorial conflict. Society might be modular rather than centralized. Territory over cities. Would they build permanent settlements? Probably not in the way we imagine cities. Why? Because their ecology is mobile. Grasslands shift, climate fluctuates, migration routes matter. A highly mobile society doesn't invest in fixed architecture. Instead, territory becomes psychological rather than structural, defined by water sources, nesting grounds, seasonal feeding zones. Conflicts would likely revolve around these resources. And that brings us to the uncomfortable question, would intelligent dinosaurs wage war? Conflict as biological conflict emerges when resources are scarce, territory overlaps, reproduction is threatened. These pressures exist in almost all ecosystems. So yes, conflict would almost certainly exist, but it might not look like human warfare. No metal weapons, no fortresses, no siege engines. Conflict could resemble coordinated group intimidation displays, strategic ambushes, territorial skirmishes, vocal signaling contests. Energy conservation is critical in evolutionary systems. Total annihilation is rarely efficient. Dominance displays may prevent large-scale violence most of the time. Modern wolves and chimpanzees already show territorial aggression without industrial war. So intelligent dinosaurs might balance aggression with survival pragmatism. Culture without writing. Here's where things get fascinating. Culture is the transmission of behavior across generations. Writing is not required. Whales transmit songs. Birds transmit calls. Primates transmit tool techniques. An intelligent theropod society might have complex migration songs encoding route information, ritualized hunting dances, teaching strategy, seasonal ceremonies reinforcing territory bonds, vocal dialects unique to different regions. Over millions of years, dialect variation could become substantial. Communication systems might grow increasingly symbolic. Perhaps certain sound patterns represent abstract ideas like danger tomorrow or food beyond ridge. Language doesn't need lips. It needs shared neural mapping. Spirituality without stars? Would they look at the night sky and wonder? This is the hardest question. Humans developed astronomy partly because agriculture required calendar systems. Without agriculture, would intelligent dinosaurs map constellations? Maybe. Navigation could require celestial awareness. Migration over vast plains might rely on star positioning. Pattern recognition in the sky could become culturally significant. But abstract cosmology, philosophy, it's possible, but not inevitable. Curiosity emerges from surplus cognitive capacity. If survival challenges consume most mental energy, abstract thought may remain limited. Yet remember, crows solve multi-step puzzles. Octopuses escape complex traps. Intelligence is flexible. Given enough time, curiosity often blooms. Mammals in the margins. All the while, mammals remain secondary players. But here's something subtle. Competition can drive coevolution. If intelligent dinosaurs dominate openly, mammals might adapt to hyper-specialized niches. Nocturnal intelligence, underground societies. Small, hidden, but clever. They may never rule the surface, but they may become masters of shadow ecosystems. Evolution rarely eliminates possibility entirely. It just redirects it. A planet of balanced minds. Picture Earth now, 80 to 100 million years after the asteroid that never was. Intelligent theropods roam in organized territorial groups. They communicate richly. They use simple tools. They manage ecosystems behaviorally. They do not industrialize. They do not mine fossil fuels. They do not create plastic oceans. Forests and grasslands continue cycling naturally. Ice ages come and go. The planet breathes. Intelligence exists, but it integrates rather than dominates. And that might be the biggest difference from us. Let's pause here, because this alternate Earth is not empty. It is not primitive. It is not stagnant. It is alive with minds, just not human ones. And in Part 10, we're going to push the final frontier. Could an intelligent dinosaur civilization ever reach space? Or is space exploration uniquely tied to human anatomy, psychology, and historical accident? Because reaching the stars requires more than intelligence. It requires obsession. Part 10. Would they ever reach the stars? Let's go all the way. We've imagined intelligent dinosaurs. We've imagined tool use, territories, migration songs, complex communication, behavioral culture. But now we're stepping into the ultimate question. Would they ever look up at the night sky and decide to leave Earth? Because reaching space is not just about intelligence. It's about dissatisfaction. It's about curiosity that refuses to stay grounded. It's about turning survival tools into abstract engineering. And that's a very specific psychological cocktail. Step 1. Looking up. Any intelligent species will notice the sky, especially one that migrates. Stars are navigation markers. Patterns repeat. Seasons shift with constellations. Over millions of years, pattern recognition might evolve into primitive astronomy. They might map the sky. They might encode stellar positions into migration songs. They might even develop myths, symbolic interpretations of recurring celestial movements. But astronomy alone doesn't create rockets. Humans observe stars for tens of thousands of years before building telescopes. So what pushes a species from observation to ambition? The energy barrier. Spaceflight requires enormous energy concentration. You need advanced metallurgy, controlled combustion, chemical engineering, mathematics, precision manufacturing. All of that stems from cumulative technological escalation. Humans didn't invent rockets directly. We invented fire control to pottery, to metal tools, to agriculture, to cities, to mathematics, to physics, to engines, to rockets. It was a chain reaction spanning thousands of years. Now ask yourself, would intelligent dinosaurs ever begin that chain? Remember their ecological model. They're mobile. They don't rely on agriculture. They don't build permanent cities. They regulate ecosystems rather than dominate them industrially. Without food surplus and urban density, technological specialization remains limited. No surplus leads to no full-time engineers. No full-time engineers leads to no industrial revolution. And without industry, space remains unreachable. The psychology of expansion. There's something else. Humans are restless. We overexploit. We compete aggressively. We push boundaries. Some of that comes from primate social dynamics, hierarchy, by competition, alliance building, our evolutionary history selected for expansion. But intelligent dinosaurs might not share that trajectory. If their dominant strategy is ecological integration rather than resource extraction, they might not feel compelled to conquer environments. Survival doesn't demand rockets, and evolution doesn't reward unnecessary risk. Launching into space is risky, extremely risky. Evolution favors stability unless instability creates opportunity. A stable planet, no pressure. In our timeline, space exploration partly emerged from geopolitical competition. War accelerated rocketry. Competition fueled innovation. But in a dinosaur-dominated Earth without agriculture, cities, or industrial war, there may be less incentive for technological arms races. Conflict may exist. Territorial disputes may occur. But without metallurgy, combustion chemistry, and population density, escalation remains limited, which means the technological ceiling might remain low. Not because they aren't intelligent, but because their environment doesn't demand escalation. Could flight inspire them? Here's a fascinating twist. Dinosaurs gave rise to birds. Flight already exists in their lineage. If intelligent theropods share ancestry with flight-capable species, they might deeply understand aerodynamics through observation. They might experiment with gliding structures. They might refine artificial wing-like tools. But flight and spaceflight are separated by a canyon of complexity. Even humans mastered flight only in the early 1900s, and spaceflight followed decades later. Without industrial materials, precise machining, and combustion engines, flight remains biological, not mechanical. The long-term possibility. Let's stretch imagination further. Suppose over tens of millions of years, incremental innovations accumulate. Stone tools improve, symbolic communication strengthens. Primitive agriculture emerges in isolated regions. Settlements slowly form, population density increases. At some point, metallurgy might be discovered accidentally, perhaps from natural volcanic exposure of metals. Then, specialization begins. Then cumulative technology accelerates. In that extremely long scenario, yes, spaceflight becomes theoretically possible. But here's the catch. That path requires breaking out of ecological integration. It requires shifting from balance to transformation. And that psychological shift may never occur if the ecosystem remains stable. Humans industrialized partly because we destabilized our own environment. Scarcity drives innovation. Competition accelerates it. A balanced dinosaur world may not generate that same pressure. The irony of mammals. And here's the cosmic irony. In this alternate Earth, mammals never dominate. But mammals are uniquely suited, anatomically and behaviorally, for fine motor control, abstract symbolic thought, and technological escalation. Without mammals taking over, space exploration may remain forever unrealized. The universe remains unwitnessed by telescopes. The moon remains untouched. Mars remains silent. Stars shine, but no one calculates their distance. The quiet cosmos picture that version of Earth. It's been 100 million years since the asteroid that never was. Intelligent dinosaurs roam continents. They manage territories. They communicate richly. They use tools. They sing migration routes under constellations. They understand patterns. Maybe they even have proto-mythologies about the sky. But they never leave. The moon remains a distant silver disk. The planets remain wandering lights. The galaxy remains unknowable. And the universe continues expanding. Unobserved. The final realization. Here's what this entire journey reveals. Intelligence is not a guarantee of technology. Technology is not a guarantee of spaceflight. And spaceflight is not a guarantee of survival. Humans reach the stars not because evolution aimed for it, but because a chain of unlikely events aligned. Asteroid impact, mammalian radiation, primate evolution, bipedalism, fire control, agriculture, cities, war, science, industrialization. Remove the asteroid, and that entire chain dissolves. We began this journey with a simple question. What if dinosaurs never went extinct? Now we've traveled through forests, oceans, grasslands, social evolution, intelligence, culture, and finally, the stars. And the answer is not just about dinosaurs, it's about us. We exist because extinction happened, because catastrophe created opportunity, because randomness shaped destiny. And maybe, just maybe, the most extraordinary thing about Earth isn't that dinosaurs ruled it for 160 million years. It's that a single rock from space gave rise to a species capable of asking this question at all. Take a moment. Look up tonight if you can. The sky you see is the result of survival by accident, and that might be the most astonishing story of all. Part 11. The Fragile Thread of Chance. Let's zoom out one final time. Not to dinosaurs, not to mammals, not even to Earth. Let's zoom out to probability itself. Because after everything we've imagined, forests without extinction, intelligent theropods a sky never reached, we arrive at a deeper realization. Evolution is not a ladder, it's a branching storm of accidents. And intelligence? It may be far rarer than we're comfortable admitting. 4.5 billion years of silence Earth formed about 4.5 billion years ago. For most of that time, there was no complex life. For over 3 billion years, life remained microscopic. Single cells, microbial mats, simple chemical existence. Multicellular life is recent. Complex animals are extremely recent. Dinosaurs ruled for 160 million years, a staggering stretch. Humans? We've existed for roughly 300,000 years. Technological civilization? About 10,000. Industrial civilization? Barely 200. Spaceflight? 60. On a cosmic timescale, we're not even a blink. We're a spark. That means something profound. If the asteroid had missed, that spark may never have ignited. Intelligence isn't inevitable. We often assume intelligence is the natural endpoint of evolution. But look at Earth's history. For billions of years, evolution never bothered creating high-level abstract reasoning. Why? Because intelligence is expensive. Brains require enormous energy. They're metabolically costly. They increase vulnerability at birth. They demand long development periods. Evolution doesn't favor complexity unless it increases survival. For dinosaurs, being big, strong, fast, and reproductively successful was enough. For millions of years, that worked. No pressure demanded human-level cognition. No crisis required symbolic mathematics. No catastrophe forced planetary engineering. Remove the asteroid, and that pressure never arrives. The Great Filter question. There's a concept in astrobiology called the Great Filter. It asks, at what stage does life usually fail? Is simple life common? Is complex life rare? Is intelligence rare? Is technological civilization extremely rare? Is self-destruction inevitable? We don't know. But this alternate Earth scenario hints at something unsettling. Even if life flourishes, even if intelligence emerges, technological civilization may not. And if technological civilization is required for space exploration, then the galaxy could be full of intelligent species who never leave their planets. A universe of unseen minds. Imagine millions of worlds where evolution thrives. Ecosystems stabilize apex predators, evolve social intelligence, communication systems form, cultures develop, but none of them industrialize. None of them burn fossil fuels. None of them invent radio telescopes. None of them split atoms. They live, they adapt, they evolve, and they disappear when their star ages. The universe would be teeming with life, yet silent. No signals, no probes, no spacecraft. Just biospheres blooming and fading quietly. The paradox of our success. Here's the uncomfortable truth. What allowed us to reach space may also threaten our survival. Industrialization, resource extraction, mass energy use, global competition. These forces gave us rockets, but they also gave us climate instability, nuclear weapons, ecological collapse risks. Our path to the stars runs directly through self-destruction territory. An intelligent dinosaur civilization that never industrializes might survive hundreds of millions of years longer than we will. They may never touch the moon, but they may never destabilize their biosphere either. So which is more advanced? The species that reaches orbit, or the species that remains in balance? That question has no easy answer. The cosmic lottery. The asteroid 66 million years ago wasn't just a disaster. It was a pivot point in probability space. It eliminated dominant species. It reshuffled ecosystems. It created ecological vacancies. It opened evolutionary doors. Without it, no primate radiation, no hominins, no Homo sapiens, no science, no telescopes, no satellites, no Voyager probe drifting beyond the solar system. One impact, one moment, one cosmic roll of the dice. And here we are. Awareness is the real miracle. After all this, here's what might matter most. We are aware of our contingency. We can imagine alternate timelines. We can reconstruct mass extinctions. We can model evolutionary trajectories. We can ask, what if we never existed? That self-reflective capacity is extraordinarily rare, at least as far as we can observe. Dinosaurs ruled Earth longer than humans have existed, but we are the species that contemplates their absence. That may be the most astonishing twist of all. A final thought experiment tonight. Imagine two Earths. On one, feathered intelligent theropods roam endless grasslands. Migration songs echo under unpolluted skies. No cities glow at night. No satellites orbit above. On the other, humans have built cities visible from orbit. Rockets pierce the atmosphere. Radio waves leak into space. A probe travels beyond Pluto, carrying a golden record. Both worlds are products of evolution. Only one exists. And it exists because extinction happened. The rock that changed. Everything we often think of extinction as loss. But extinction is also transformation. The asteroid did not create humans. It created possibility. It disrupted dominance. It reshaped ecosystems. It altered the trajectory of life. Without catastrophe, evolution might stagnate in stable patterns. With catastrophe, pathways open. We are, in a strange way, descendants of disaster. The quiet responsibility. If intelligence and spaceflight are rare, if technological civilization is fragile, if the universe may be mostly silent, then our existence carries weight. We may be one of very few species that reach this stage, or one of many who briefly flare before fading. Either way, we are here, aware, capable of preserving or destroying, capable of exploring or collapsing. The asteroid gave us the opportunity. What we do with it is no longer random, it's a choice. And that's where this journey ends. Not with dinosaurs, not with extinction, but with us, standing on a small planet under a vast sky, aware that our story began with a rock from space, and wondering, what story comes next? Part 12, the timeline that almost was. We've reached the end of this alternate Earth. Dinosaurs never went extinct, mammals never rose, humans were never born, the sky remained untouched. But before we close the story, let's do something different. Let's rewind one more time. Not to the asteroid, not to the dinosaurs. Let's rewind to the moment before impact, 66 million years ago. A rock roughly 10 kilometers wide hurtles toward Earth. If it misses by just a few minutes in orbital timing, everything changes. And here's the haunting part. In a universe governed by physics, that miss was entirely possible. A planet on the edge. The late Cretaceous world was not collapsing. It was thriving. Forests stretched across continents. Flowering plants diversified, insects flourished. Dinosaurs filled ecological roles from small gliders to giant apex predators. There was no sign that their reign was ending. No evolutionary signal that mammals were about to inherit the Earth. No biological warning system. Life was stable. Stable systems can persist for millions of years. Without external disruption, dominance often continues, which means the asteroid wasn't just an event. It was an interruption of equilibrium. The power of near misses. In cosmic terms, near misses happen constantly. Asteroids pass by Earth regularly. Some burn in the atmosphere. Some skim past in silence. History is shaped as much by what doesn't happen as by what does. Think about that. If just one variable in gravitational interaction had shifted slightly, the impact never occurs. Dinosaurs continue. Mammals remain small. No extinction event clears ecological space, and evolution flows along a completely different channel. That fragility should make you pause. Because our existence hangs on a statistical knife edge. The age of dinosaurs could have lasted. Dinosaurs had already survived. Massive volcanic eruptions, climate shifts, sea level changes, continental drift. They were adaptable. They weren't evolutionary dead ends. They were successful. There's no clear reason their reign would have naturally ended soon. They might have dominated another 50 million years, or 100 million, or longer. If intelligent forms emerged slowly within their lineages, it might have taken tens of millions of years more, but the opportunity was there. Given enough time, complexity tends to increase somewhere. It just isn't guaranteed to escalate into industry. Our timeline is the exception. Here's the radical idea. Maybe human civilization isn't the default outcome of life. Maybe it's the anomaly. In our timeline, a catastrophic extinction occurred, a small mammal lineage survived, primate intelligence evolved, bipedalism freed hands, language amplified cooperation, agriculture created surplus, surplus created cities, cities created specialization, specialization created science, science created rockets. That is not a simple chain. It's a cascade of improbabilities. Remove one link and the cascade fails. In the dinosaur timeline, most of those links never appear. Not because they are impossible, but because they are unnecessary. The double-edged flame. We often celebrate fire as the turning point of humanity. Fire gave us protection, cooking, heat, metallurgy, industry. But fire also accelerated our ecological footprint. Intelligent dinosaurs might never master controlled fire. Or if they did, it might remain ritualistic or localized. Without fire-driven industry, their world remains biologically regulated. Forests regrow. Carbon cycles balance. Extinction rates remain natural. Contrast that with us. We altered atmospheric chemistry in less than 200 years. That's astonishing and dangerous. Our path to power is also our path to fragility. What if we're early? There's another possibility. Maybe intelligent life is rare, not because it fails, but because it takes time. The universe is 13.8 billion years old. Complex life on Earth took billions of years to appear. Maybe most planets are still in microbial stages. Maybe many are in dinosaur-like stages. Maybe technological civilizations are just beginning to flicker into existence across the cosmos. If so, we're not late. We're early. And that thought carries responsibility, because early civilizations shape cosmic history. The privilege of perspective. The most extraordinary thing about this entire exploration isn't dinosaurs. It isn't extinction. It isn't alternate evolution. It's perspective. We can reconstruct deep time. We can simulate alternate histories. We can calculate asteroid trajectories. We can measure starlight from galaxies billions of light years away. Dinosaurs never had telescopes. Intelligent theropods might never build them. But we did, and that means we can see our contingency clearly. We know we are not inevitable. We are a branch, not the trunk. The quiet warning. There's a subtle message hidden in this alternate Earth. Stability can last millions of years, but disruption changes everything. The asteroid was random. Our modern disruptions are not. Climate change, biodiversity loss, nuclear risk, these are not cosmic accidents. They're consequences of intelligent choice. Dinosaurs couldn't choose to deflect an asteroid. We can. Dinosaurs couldn't measure atmospheric CO2. We can. That difference is enormous, and it places us in a position evolution has never tested before. Conscious planetary stewardship. The final frame. Imagine two scenes. Scene 1. A feathered theropod stands on a ridge 50 million years after the missed asteroid. The air is clean, the forests endless. Stars glitter overhead. No artificial lights interrupt the darkness. Scene 2. A human astronaut looks down at Earth from orbit. Cloud systems swirl over continents. City lights glow on the night side. Satellites trace invisible lines around the planet. Both are intelligent. Only one left the surface. Only one understands extinction as history. Only one knows an asteroid almost erased everything. The story isn't over. This series began with a question about dinosaurs. It ends with a question about us. What will future life say about this era? Will we be the brief industrial flare before collapse? Or the first species to survive long enough to become interplanetary? The asteroid created opportunity. Evolution created awareness. Now awareness must create wisdom. Because unlike the dinosaurs, our extinction, if it comes, won't be random. It will be chosen or prevented. And that is the most powerful difference of all. Look up tonight, not just in wonder, but in awareness. The sky above you is the result of survival through catastrophe. And the future of that sky? For the first time in Earth's history, it may depend on conscious decision. Part 13. The future beyond us. We've imagined a world without the asteroid. We've walked through forests ruled by feathered predators. We've watched mammals stay small. We've imagined intelligent dinosaurs who never build rockets. We've reflected on chance, on extinction, on fragility. Now let's ask the final, uncomfortable question. What happens after us? Because if extinction created opportunity once, it can do it again. Civilizations are thin layers. Human civilization feels permanent. Skylines, satellites, digital networks, global trade. But geologically speaking, we are a thin film, a chemical signature in sediment, a faint radioactive layer in rock. If humanity vanished tomorrow, forests would reclaim cities within centuries. Steel would rust, concrete would crack, plastics would fragment. In a few million years, most evidence of us would be buried. In tens of millions of years, our existence might be a puzzle in the fossil record. Dinosaurs ruled for 160 million years. We've industrialized for 200. That contrast is humbling. A second rise of reptiles? If humans disappeared, whether by self-inflicted collapse or natural disaster, evolution wouldn't stop. It never stops. Vacant niches invite new experiments. Mammals might persist. Birds, the direct descendants of dinosaurs, are already incredibly intelligent in some lineages. Corvids solve complex puzzles. Parrots demonstrate symbolic learning. Octopuses, though not vertebrates, show startling cognition. Given millions of years, new dominant intelligences could emerge. They might not look like us. They might not build cities. They might not even develop technology. But evolution doesn't require our blueprint. It only requires time. The long view of Earth. The Sun has about 5 billion years left before it expands into a red giant. Long before that, Earth's climate will gradually shift as solar luminosity increases. Oceans may evaporate in roughly 1 to 2 billion years. Complex life may become impossible. That means Earth's window for advanced civilization is finite. A blink in cosmic time. If intelligent life is rare, and if technological civilization is rarer still, then this window matters enormously. We are not just one species among many. We may be one of very few that reached awareness during this planetary window. The pattern of collapse history shows something important. Civilizations rise. Civilizations strain resources. Civilizations collapse or transform. But global industrial civilization is new. Never before has one species altered planetary systems at this scale. Never before has one species possessed the power to trigger nuclear winter. Never before has one species been able to monitor asteroid threats in advance. We are simultaneously powerful and fragile. That tension defines our era. And here's the eerie parallel. The asteroid that ended the dinosaurs was external. The potential extinction level risks we face are internal. That's unprecedented. The possibility of continuity. There's another path. A path where humanity survives, stabilizes climate, manages ecosystems responsibly, expands carefully into space, becomes multiplanetary. If that happens, extinction no longer resets the board so easily. A species spread across multiple worlds is harder to erase. The asteroid that ended dinosaurs couldn't reach beyond Earth. A spacefaring civilization changes the rules, and that might be the true long-term evolutionary leap. Not intelligence, not cities, not rockets, but redundancy. Survival beyond one planet. The evolution of intelligence may not be the final step. It may be transitional. Biological evolution produced brains. Cultural evolution produced science. Technological evolution produced computation. Artificial intelligence, genetic engineering, planetary engineering. These are new layers of evolution. If humanity persists, evolution may shift from natural selection to directed selection. We may guide our own trajectory. Dinosaurs never had that chance. We do. That makes our timeline uniquely volatile and uniquely full of possibility. A mirror to the dinosaur world. Let's return briefly to our alternate Earth. In that world, dinosaurs never industrialize. They remain ecologically integrated. They survive for millions more years. They never leave the planet. In our world, we industrialize rapidly. We destabilize ecosystems. We reach space quickly. We risk collapse sooner. Which path lasts longer? The stable biosphere without rockets? Or the unstable biosphere reaching for the stars? The answer isn't obvious, and that's the paradox. The silent universe revisited. If most intelligent species remain planetary, if few industrialize, if fewer still survive long enough to expand, then the universe may be quiet not because life is rare, but because sustained technological survival is rare. Maybe countless civilizations flare briefly and vanish. Maybe we're watching the early chapters of a cosmic pattern, Or maybe we are the exception that endures. We don't know. That uncertainty is both terrifying and exhilarating. The responsibility of being here. The asteroid shaped our origin, but it doesn't shape our future. For the first time in Earth's history, a species understands extinction as a concept. We study past mass extinctions. We track near-Earth objects. We model climate trajectories. We debate ethical futures. Awareness doesn't guarantee wisdom, but it creates the possibility of it. Dinosaurs never had to choose planetary stewardship. We do. The final perspective. Imagine Earth 100 million years from now. Scenario 1. Humanity collapsed. New lineages evolved. Our cities became fossilized anomalies. Scenario 2. Humanity survived, expanded, transformed. Left Earth as a protected biosphere while civilizations flourish elsewhere. Both are plausible. The asteroid shows us how small events shape destiny, but now the shaping force is internal. Choice replaces randomness. That's a profound shift in evolutionary history. Closing the circle. We began with a simple hypothetical. What if dinosaurs never went extinct? We imagined forests of giants, intelligent theropods, a planet without industry, a silent sky. And in the end, we returned to ourselves. Because alternate histories aren't really about the past. They're mirrors. They show us contingency, they show us fragility, they show us possibility. Dinosaurs ruled for 160 million years and vanished in a geological instant. We have ruled for a fraction of that time. The difference is not power, it's awareness. And awareness is both a gift and a burden. The asteroid was chance. The future won't be. What happens next is up to us. Part 14. The last thought before the silence. We've traveled across 160 million years of dominance. We've erased an asteroid. We've imagined intelligent dinosaurs. We've compared their world to ours. We've confronted extinction, past and future. Now we arrive at something quieter. Not a new scenario, not a new species, but a final shift in perspective. Because the deepest lesson of this entire journey isn't about dinosaurs. It's about fragility. The illusion of permanence stand in any modern city. Glass towers, concrete highways, satellites overhead, billions of humans connected in real time. It feels permanent. But permanence is an illusion created by short lifespans. A century feels long to us. A millennium feels ancient, but geological time erases both effortlessly. Dinosaurs once dominated every continent. They were not primitive failures. They were extraordinarily successful, yet in a geological instant, gone. Not gradually, not predictably, abruptly. And if we're honest, our civilization is not immune to abruptness. The comfort of dominance. When a species dominates for long enough, dominance begins to feel natural, inevitable, deserved. Dinosaurs likely experienced no awareness of vulnerability. They had no concept of planetary risk, no astronomy, no early warning system. They ruled and assumed the world would continue as it always had, until it didn't. There's a subtle warning in that. Dominance breeds complacency, and complacency magnifies shock. The difference this time. Here's the strange twist. We are not dinosaurs. We know extinction is possible. We've mapped the crater. We've dated the impact layer. We've tracked near-Earth asteroids. We've simulated planetary collapse scenarios. Awareness changes the equation. It doesn't eliminate risk, but it transforms blind fate into calculated probability. That shift, from ignorance to foresight, may be the most important evolutionary leap of all. Intelligence is a threshold. For billions of years, life adapted unconsciously. Mutation, selection, extinction, radiation. No intention, no planning. Then intelligence crossed a threshold. For the first time, evolution produced a species capable of modeling its own extinction. That is unprecedented. Dinosaurs couldn't choose differently. We can. And that creates tension. Because with choice comes responsibility. the fragile present. Look at Earth today, ice sheets retreating, species disappearing, atmospheric chemistry shifting, technologies accelerating faster than regulation. We live in a compressed era of change. What took millions of years in the past now happens in decades. Speed amplifies instability. Dinosaurs experience gradual shifts punctuated by rare catastrophes. We experience rapid shifts driven by ourselves. The asteroid was external pressure. Our greatest risks are internal. That difference matters. The quiet possibility. But here's something hopeful. The same intelligence that destabilizes can stabilize. The same global networks that spread misinformation can spread cooperation. The same rockets that build weapons can deflect asteroids. Technology is not destiny. It's a tool. And tools amplify intention. The question is not whether we are powerful. We are. The question is whether we mature faster than our power expands. A thought experiment reversed. Let's flip the original scenario one last time. Instead of asking, what if dinosaurs never went extinct? Ask, what if humans learn from extinction? What if we treat the asteroid event not just as history, but as instruction? It tells us dominance is temporary. Stability can vanish instantly. Ecological balance matters. Chance shapes destiny. And most importantly, survival is not guaranteed. The cosmic perspectives zoom out even further. Earth is a small planet orbiting an average star in a galaxy with hundreds of billions of stars, where there are billions of galaxies. From that vantage point, human drama shrinks. But meaning doesn't. Because meaning is local. Consciousness is local. Experience is local. If intelligence is rare, even extremely rare, then each instance matters. A universe without observers is silent. A universe with even one reflective species becomes aware of itself. That's extraordinary. The rock and the mirror. The asteroid that ended the dinosaurs was a rock, cold, unfeeling, oblivious. It didn't intend to reshape evolution, it simply followed gravity. Yet its impact created the conditions for primates, for language, for science, for this thought experiment. That rock is both destroyer and ancestor, and it serves as a mirror. Because today, we hold forces just as powerful. Nuclear arsenals, artificial intelligence, climate systems. We are now the asteroid, capable of reshaping the future in a geological instant. The difference, we are conscious. The final image, imagine Earth, 200 million years from now. The continents have shifted. Mountain ranges have risen and eroded. Maybe humans are long gone. Maybe descendants thrive among the stars. Maybe another intelligence walks the surface. The rocks will remain. The layers will record. Fossils will tell fragments of the story. And somewhere in the strata, there will be a thin line marking our era. Future minds, if they exist, may study it. They may ask, what happened here? Just as we asked about the dinosaurs. The last question. This entire journey began with curiosity about a missed asteroid. It ends with a different question. Will future beings ask about us the way we asked about them? Will we be a brief anomaly in deep time? Or the beginning of something enduring? The asteroid was chance. Our future is choice. And that is the single greatest divergence between us and the dinosaurs. Take a breath. Feel the ground beneath you. It has survived continents colliding, ice ages advancing, asteroids striking, extinctions unfolding. You are standing on a planet shaped by catastrophe and resilience. The dinosaurs had no warning. We do. And that may be the most important fact in Earth's entire history. The silence after extinction is absolute. The silence before it is where decisions are made. Part 15. After the echo. We've reached the edge of imagination. Dinosaurs survived. Dinosaurs evolved. Dinosaurs perhaps even thought. Then we return to ourselves. Extinction, chance, responsibility, choice. But there's one final layer to uncover. Not about biology, not about asteroids, not about evolution, about time. Because time is the real protagonist of this entire story. The deep current beneath everything we experience time as seconds, minutes, years. Evolution experiences time as pressure. Planets experience time as erosion. Stars experience time as fuel consumption. The dinosaurs had time. 160 million years of it, long enough to adapt to shifting continents, long enough to diversify into thousands of species, long enough to dominate land, sea, and sky. They had abundance of duration. What they did not have was interruption. And interruption is what rewrites destiny. The rhythm of catastrophe. If you zoom out across Earth's history, extinction is not rare. It's rhythmic. 5 major mass extinctions before ours. Each one reshaped life dramatically. Each one cleared space for something new. Life doesn't move in smooth lines. It pulses. Expansion, stability, shock, reorganization. Dinosaurs flourished in stability. We emerged from shock. Now we live in acceleration, and acceleration changes the rhythm. Awareness alters the pattern. For the first time in Earth's 4.5 billion year history, a species can interrupt the rhythm deliberately. We can deflect asteroids, monitor supervolcanoes, predict climate shifts, store knowledge digitally across continents. That changes extinction from fate to management. Not prevention, nothing is absolute, but management. Dinosaurs could not manage their extinction risk. We can attempt to manage ours. That difference may define whether we become a brief flare or a long chapter. The weight of continuity. Imagine something radical. Humanity survives for 1 million years. Not 1,000. Not 10,000. 1 million. Cities would transform beyond recognition. Language would evolve. Technology would merge with biology. Our descendants might look nothing like us. But continuity would exist. Compare that to the dinosaurs' 160 million years. We are still infants in evolutionary terms. The real question isn't whether we are advanced. It's whether we can become stable. Stability versus intensity. Dinosaurs optimized stability. They thrived within ecological limits. They didn't mine fossil fuels. They didn't alter atmospheric chemistry at scale. They didn't split atoms. Their intensity was biological, not technological. Humans optimized intensity. We compress energy. We accelerate communication. We multiply population rapidly. Intensity brings power, but power amplifies consequences. The asteroid was sudden and external. Our disruptions are cumulative and internal. If we survive, it will be because intensity transitions into stability. That transformation is the real evolutionary test. The echo of alternate Earth. Return one last time to the dinosaur-dominated world. No asteroid, no mammals rising, no human civilization, no satellites blinking across orbit. That world might have lasted tens of millions of additional years in quiet equilibrium. Forests breathing, predators hunting, seasons turning. No global collapse, no planetary engineering. Just continuity. It's tempting to romanticize that world. But remember, it would also be a silent universe. No poetry about stars. No curiosity about galaxies. No awareness of deep time. Stability without reflection. Our world is unstable, but aware. That tension is the defining contrast. The long silence ahead. Eventually, Earth will change beyond habitability. The sun will expand. Oceans will boil away. Atmosphere will strip. Long before that, life will struggle. If no species leaves the planet, life's story ends here. Dinosaurs were bound to Earth. So are we, for now. Space is not luxury. It may be longevity. Not conquest, continuity. The difference matters. The first generation. We might be the first generation capable of planetary self-preservation. Think about that. All of evolutionary history led to unconscious adaptation. We are the first to consciously adapt the planet. That's not triumph. It's responsibility. The asteroid was blind. We are not. And blindness versus awareness may determine whether the next mass extinction is natural or chosen. The final reflection. If dinosaurs had developed intelligence just slightly earlier, if they had built early observational systems, if they had mapped celestial objects, if they had tracked incoming threats, could they have survived? Maybe, maybe not, but they never had the chance. We do, and that chance is fragile. After the echo, when the dinosaurs vanished, the world fell silent. Then mammals whispered into the ecological gaps. Then primates climbed trees. Then language formed, then science, then rockets. All of that emerged from silence. The asteroid's echo is still with us. Every fossil, every crater sample, every extinction model. It reminds us, dominance is temporary. Chance is powerful. Awareness is rare. The next chapter isn't written in stone, it's written in decision. The last frame picture. Earth from space once more. Blue oceans, white clouds, a thin atmosphere glowing at the edge. That thin layer holds every forest, every ocean, every memory, every fossil of dinosaurs, and every city of humans. It survived asteroid impacts. It survived ice ages. It survived continental collisions. Now it hosts a species capable of reflection. That is unprecedented. The dinosaurs ruled without awareness. We rule with it. The future will judge which is more sustainable. And so this journey ends, not with extinction, but with possibility. Dinosaurs remind us how long dominance can last. The asteroid reminds us how quickly it can end. Awareness reminds us that the next outcome is not purely chance. Time is still flowing. The question is simple. Will we become another layer in the rock, or the first species to carry Earth's story beyond it? The silence after extinction is final. The silence before it is the space where history changes. Part 16. The species that knows. We began with a rock, a 10-kilometer asteroid, a flash brighter than the sun, a shockwave that ended an empire 160 million years in the making. We removed that rock and watched dinosaurs continue. We restored it and watched mammals rise. We imagined intelligence in feathers. We imagined silence among the stars. We imagined futures without us. Now, in this final chapter, we arrive at the strangest conclusion of all. We are the species that knows, and that changes everything. Knowing is an evolutionary mutation. Evolution usually works on bodies, longer legs, sharper teeth, better camouflage. But awareness is different. Awareness is evolution turning inward. It is a brain capable of simulating futures, modeling risks, imagining extinction, inventing alternate timelines. No dinosaur ever wondered about the Permian extinction. No tyrannosaur debated atmospheric chemistry. They lived entirely in the present. We do not, and that might be the rarest trait on Earth. The first geological actor. For billions of years, Earth's major changes came from asteroids, volcanoes, plate tectonics, orbital cycles. Then something unprecedented happened. A biological species became a geological force. We alter carbon cycles. We reshape coastlines. We move more sediment annually than most rivers. We modify ecosystems globally. In geological terms, this is extraordinary. Life influenced Earth before, oxygenation by microbes, coral reef formation, but never at this speed. The dinosaurs were dominant. We are transformative. The double edge of conscious power consciousness amplifies impact. We can protect biodiversity, or eliminate it. We can detect asteroids, or ignore them. We can stabilize climate, or accelerate collapse. The asteroid that ended dinosaurs was blind. Our influence is not. That difference creates moral gravity. Because when change is conscious, responsibility emerges. Dinosaurs had fate. We have agency. The evolution beyond biology. There is another twist. Biological evolution moves slowly. Generations, mutations, selection. But cultural evolution moves fast. Ideas spread in seconds. Technology iterates yearly. Knowledge accumulates exponentially. If dinosaurs had evolved intelligence, their progress might have taken millions of years. We moved from stone tools to satellites in a geological blink. That acceleration is unprecedented, and acceleration is unstable by default. The real question is whether cultural evolution can mature before it destabilizes the biosphere that supports it. The rare window. Earth's habitable window is finite. the sun will grow brighter over time. Complex life likely has less than 2 billion years remaining. That sounds distant, but consider, dinosaurs ruled for 160 million years, less than 10% of that window. Human technological civilization has existed for less than 0.00001% of it. We are in the earliest fraction of our planetary chapter, which means this era may be formative. The choices made in these centuries could ripple for millions of years. The lesson of the missed asteroid. If the asteroid had missed, Earth would likely remain biologically rich but technologically silent. If the asteroid had struck slightly differently, perhaps mammals wouldn't have survived either. History is not destiny. It is probability shaped by contingency. We are not inevitable. We are an outcome of layered accidents. That realization can produce humility or arrogance. Humility says, we are lucky. Arrogance says, we are entitled. One of those mindsets sustains civilizations. The other erodes them. The threshold. Civilization. Maybe humanity is not the final form. Maybe we are a threshold species. The first to awaken. The first to manipulate planetary systems. The first to contemplate leaving, but not necessarily the last. If we survive long enough, evolution may continue through us. Genetically, technologically, even digitally. If we fail, evolution resets again. The difference between those paths lies in foresight. Dinosaurs had duration. We have direction. The universe waiting. The universe is vast and ancient. If intelligent civilizations are common, some must be millions of years older than us. If they are rare, we may be among the first. Either way, the silence is striking. No confirmed signals, no visiting probes, no clear cosmic neighbors. Perhaps most civilizations collapse early. Perhaps stability is harder than intelligence. If that's true, then we are living in the most precarious stage, the adolescence of power. The final perspective shift. This entire exploration asked, what if dinosaurs never went extinct? But maybe the deeper question is, what if extinction is not the point? What if awareness is? Extinction reshapes ecosystems. Awareness reshapes possibility. Dinosaurs mastered their environment unconsciously. We attempt to master it consciously. The outcome of that experiment is still unfolding. The species that know stand outside at night. Look at the moon. That same moon shone over tyrannosaurs, over triceratops, over forests that no longer exist. They never questioned it. They never imagined landing there. We did. And we did land there. That leap, from observation to exploration, is not trivial. It is the difference between being part of the biosphere and analyzing it, between living in time and measuring it, between surviving extinction and preventing it. The final choice. The asteroid created an opening, evolution filled it, intelligence amplified it. Now the story is no longer purely natural. It is participatory. We are actors in Earth's future, not just inhabitants. Dinosaurs could not choose to avoid their extinction. We may be able to avoid ours. That is not guaranteed. But it is possible, and possibility is powerful. Closing the journey. If dinosaurs had never gone extinct, the world might be stable, ancient, and silent. Because they did, the world became unstable, young, and aware. We are the outcome of catastrophe and chance. But we are also the beginning of intention. The next extinction event will not ask permission, but we might. And that makes us different from every species that came before. We are the species that knows. What we do with that knowledge will decide whether our chapter becomes a brief anomaly in rock layers or the moment Earth's story reached beyond itself. Part 17. The Day After Awareness. We've arrived at the quietest chapter of this journey. Not extinction, not asteroids, not dinosaurs rising or falling, but the morning after awareness. Because once a species realizes it exists in deep time, once it understands extinction, probability, fragility, something irreversible happens. You can't unknow it. And we are living in that irreversible moment. The morning after discovery. There was a time when humans did not know dinosaurs existed. Their bones lay buried. their world forgotten. Then we found them. We reconstructed skeletons, mapped craters, measured iridium layers, understood the asteroid. And suddenly, Earth's story expanded. We realized life can dominate for 160 million years and still vanish. That realization changed how we see ourselves. It shattered the illusion that dominance equals permanence. Now the question becomes, what does a species do after it understands that? Knowledge as a turning point. There are two possible reactions to awareness: denial, transformation. Denial says, extinction happened to them, not to us. Transformation says, if it happened before, it can happen again. Dinosaurs never had this psychological fork in the road. We do. And history suggests that civilizations often struggle at this crossroads. Short-term comfort competes with long-term survival. Immediate gain competes with generational stability. Awareness doesn't automatically produce wisdom. It only creates the opportunity for it. The thin blue margin. Look at images of Earth from orbit. A glowing blue sphere. A razor-thin atmosphere hugging its surface. That thin layer is everything. Every forest, every ocean, every dinosaur that ever lived, every human city that ever rose. It is astonishingly fragile. Dinosaurs never saw it from above. They never understood planetary boundaries. We do. And that vantage point changes psychology. Seeing Earth as a single system reframes survival as collective rather than competitive. But collective thinking is evolutionarily difficult. Our brains evolved for tribes, not planets. That tension defines our era. Power, without maturity. Technological civilization grew rapidly. Agriculture took millennia to spread. Industry took centuries. Digital networks took decades. Artificial intelligence took years. Acceleration compounds risk. Dinosaurs evolved slowly with an ecological balance. We evolve culturally faster than ecosystems can adapt. That speed creates instability. The asteroid was a sudden shock. We are a continuous shock, unless we learn to moderate our own momentum. The civilizational test. Every advanced species, if they exist elsewhere, must face a similar phase. A moment when energy access explodes. Technology outruns ethics. Global systems become interconnected. Existential risks multiply. Some may collapse here. Some may stabilize. We don't know which category we belong to yet. We are mid-test. The outcome is undetermined. The shadow of deep time. Deep time humbles arrogance. Dinosaurs were not inferior. They were different. They optimized biological success. We optimized cognitive expansion. Both strategies have strengths. But biological optimization is stable. Cognitive expansion is volatile. Volatility can produce brilliance or catastrophe. If we fail, Earth will recover eventually. New lineages will evolve. The planet will not mourn us. But the loss of awareness would be immense. Conscious reflection is rare. It would vanish with us. The responsibility of memory. We remember the dinosaurs. We study them. We reconstruct their extinction. That memory allows us to model risk. Memory is evolutionary leverage. No prior species had planetary memory. We do. That means we are no longer purely biological actors. We are historical actors. We can learn. The question is whether we will. The long game Imagine Humanity adopts a 10,000-year mindset. Infrastructure built for millennia. Energy systems designed for sustainability. Ecosystems treated as capital, not expendable resources. Space expansion pursued carefully, not competitively. That long game contrasts sharply with short-term cycles of politics and profit. But deep time demands deep thinking. Dinosaurs had time without foresight. We have foresight without time to waste. A universe watching? We often wonder whether we are alone. But there's another possibility. Maybe other civilizations reached awareness and failed to mature. Maybe the universe is quiet because adolescence is lethal. If that's true, survival beyond this phase is extraordinary. It would mean passing through the narrow corridor between power and collapse. Dinosaurs never faced that corridor. We do. the day after awareness. So here we stand, after discovering extinction, after mapping deep time, after reaching space. The day after awareness is not dramatic, it's subtle. It's the slow recognition that history is fragile, that dominance is temporary, that survival now includes intention. The asteroid's echo still resonates through geology, but our choices will echo through the future, and those echoes will be louder. The final reflection. If dinosaurs had developed awareness millions of years earlier, if they had tracked celestial objects, if they had understood extinction cycles, would their fate have changed? We can't know, but we know this. We are not ignorant of risk. That knowledge is our evolutionary advantage, or our burden. Closing the arc. We began with a missed asteroid. We imagined forests untouched by catastrophe. We imagined intelligent reptiles under silent stars. And we ended here, in the present, awake, aware, capable. The difference between us and the dinosaurs is not strength. It's foresight. The next extinction event is not scheduled. But the next chapter is being written right now. And unlike every species before us, we know that. Part 18. The quiet between extinctions. We've explored dominance, we've explored catastrophe, we've explored awareness. Now let's focus on something almost invisible, the quiet. Because extinction events are dramatic. Asteroids are cinematic. Volcanoes are violent. But most of Earth's history is not chaos. It's quiet persistence. And that quiet is where the real story unfolds. The long middle. Between mass extinctions, there are vast stretches of stability. Millions of years where ecosystems adjust gradually. Predators and prey find balance. Forests expand and contract. Oceans circulate nutrients. Dinosaurs lived mostly in that long middle. Their 160 million year reign wasn't constant crisis. It was continuity. That continuity allowed complexity to grow. Species refined niches. Ecologies layered into intricate webs. Life matured. The asteroid was a punctuation mark. But the sentence was long. What stability really means. Stability doesn't mean no change. It means change within boundaries. Temperature fluctuates, but within survivable limits. Sea levels rise and fall, but ecosystems adapt. Species compete, but networks remain intact. Dinosaurs thrived because Earth systems stayed within these ranges. They didn't need radical innovation. They needed resilience. And they had it. Until they didn't. Our disrupted middle. Here's the contrast. We are not living in a long middle. We are compressing geological change into centuries. Carbon levels rising at rates unseen in millions of years. Biodiversity loss accelerating. Ocean chemistry shifting rapidly. We are shortening the quiet. And the quiet is essential. Because it's during stability that complexity deepens. If the quiet disappears, resilience weakens. And resilience is what carries life through shocks. The misunderstood danger. The asteroid was visible in hindsight. Its crater remains. Its iridium layer is measurable. But systemic destabilization is subtler. You don't feel atmospheric parts per million in daily life. You don't hear biodiversity loss. You don't see ocean acidification directly. Yet these are slow erosions of the long middle. And once thresholds are crossed, recovery can take millions of years. Dinosaurs had no role in destabilizing their own stability. We do. That difference is critical. The power of small corrections. The hopeful part? Systemic problems often require systemic thinking, not apocalyptic thinking. Small corrections sustained over decades matter. Energy transitions, reforestation, sustainable agriculture, global cooperation on existential risks. None of these are cinematic. They don't look like rockets or asteroid impacts. They look like boring policy and incremental improvement. But stability is built quietly. And so is collapse. The deep time perspective. In deep time, species that survive are not necessarily the strongest. They are the adaptable. They maintain flexibility without overshooting ecological limits. Dinosaurs were adaptable for 160 million years. Their extinction was not due to internal collapse, it was external shock. We risk creating internal shocks. That's unprecedented. If we avoid them, our reign could extend for millions of years. If we don't, it may be brief. Deep time doesn't judge morality, it records outcomes. Intelligence and restraint. There's a paradox here. Intelligence increases capability, but survival may require restraint. A predator that consumes all prey starves. A civilization that consumes its ecological base collapses. Dinosaurs operated within evolutionary checks and balances. We can override ours. That override is both our strength and our vulnerability. The test of awareness is not expansion alone. It's balance with foresight. Imagining the next quiet picture. Earth 10 million years from now. If humanity stabilizes and integrates sustainably, forests may be healthier than before industrialization. Species may recover. Cities may coexist with wild corridors. Space habitats may relieve pressure on ecosystems. The long middle could return, enriched by awareness. But if destabilization spirals, recovery will still occur. It always does, but not for us. Life will adapt without consultation, and the quiet will belong to new lineages. The dinosaur echo revisited. When dinosaurs ruled, they didn't know they were in the long middle of history. We do. We know stability is rare and precious. We know extinction reshapes everything. We know planetary boundaries exist. That knowledge is leverage. It can extend the quiet, or it can be ignored. The final realization. This journey began with a missed asteroid, but maybe the deeper lesson isn't about catastrophe. It's about preservation. The asteroid ended an era abruptly, but what defined that era was not its end. It was its long continuity. If we want a future measured in millions of years, not centuries, we must rebuild the quiet, not by returning to pre-industrial simplicity, but by integrating technology within planetary limits. Awareness without action changes nothing. Action without awareness destabilizes everything. The balance between the two defines our chapter. The space between impacts. Mass extinctions are dramatic bookends, but life's richness exists between them. The forests, the oceans, the slow evolution of complexity. That space between impacts is where meaning unfolds. We are living in that space. The next asteroid may come in thousands or millions of years. The question is whether we allow internal shocks to arrive first. Dinosaurs were undone by randomness. We risk being undone by choice. And that is the starkest difference of all, closing the quiet. Stand still for a moment. Feel the ordinary rhythm of the world, wind, birdsong, traffic hum, breath. That ordinariness is the long middle. It is fragile. It is precious. It is what allows civilization to exist at all. Dinosaurs had it for 160 million years. We have had it for a blink. The real challenge is not surviving the next asteroid. It's preserving the quiet between them. Because that quiet is where life truly thrives. Part 19. If the sky darkened again. We've talked about awareness. We've talked about stability. We've talked about the quiet between catastrophes. Now we need to confront something uncomfortable. What if the sky darkened again? Not metaphorically, literally. The return of the unthinkable asteroid impacts are not myths. They are statistical events. Earth orbits within a cosmic shooting gallery. Most objects burn up harmlessly. Some don't. The one that ended the dinosaurs was about 10 to 12 kilometers wide. But it doesn't take something that large to destabilize civilization. A 1-kilometer asteroid could cause global agricultural collapse. Even a few hundred meters across could devastate an entire region. And here's the strange twist. For the first time in Earth's history, a species is watching the sky. That species is us. The difference between them and us dinosaurs never scanned the heavens. They never tracked orbital trajectories. They never modeled impact probabilities. Or they lived under the same sky but without awareness of its dangers. We have telescopes mapping near-Earth objects. We calculate impact windows decades in advance. We design deflection strategies. For the first time, extinction from above is not purely random, it's preventable, or at least potentially preventable. That's a revolutionary shift in planetary history. The power to nudge a world imagined detecting an asteroid 20 years before impact. A small change in velocity, just a few millimeters per second, could alter its path enough to miss Earth entirely. Not by brute force, by precision. Tiny adjustments early make massive differences later. This principle applies beyond asteroids. Small actions now reshape long-term outcomes. Delay makes everything harder. Dinosaurs had no early warning system. We do. The question is whether we invest in it consistently. Beyond asteroids. The sky darkening doesn't have to come from space. Volcanic supereruptions, pandemics, nuclear conflict, uncontrolled artificial intelligence. Modern extinction risks are hybrid. Some natural, some self-created. The asteroid that ended the Cretaceous was a single external event. Our era contains multiple simultaneous vulnerabilities. That complexity raises stakes, but it also expands agency. We can mitigate many of these risks, if we choose to. The psychology of rare catastrophe. Humans struggle with low probability, high impact events. If something hasn't happened in our lifetime, it feels abstract. Dinosaurs didn't anticipate an asteroid because anticipation requires abstraction. We have abstraction, but we still discount distant threats. That cognitive bias is dangerous. The asteroid that ended the dinosaurs was inevitable in deep time. So is another impact. The only uncertainty is timing. Preparation is rational, even if the event is centuries away. Because survival is cumulative. It's built in advance. Civilizations and the filter. There's a theory about the universe called the Great Filter. It suggests that somewhere between simple life and interstellar civilization, something stops most species. Maybe it's self-destruction. Maybe it's environmental collapse. Maybe it's failure to manage planetary risks. Asteroid defense could be one of the earliest tests. A civilization that cannot protect its own planet may not last long enough to explore others. Passing this test is not about heroism. It's about coordination. Global cooperation. Shared responsibility. Dinosaurs never needed cooperation beyond ecosystems. We require planetary alignment. A world in the dark. Imagine, just for a moment, the sky dimming. Dust injected into the stratosphere. Sunlight reduced. Crops failing. Supply chains collapsing. Cities straining. The Cretaceous impact triggered a global winter lasting years. Photosynthesis halted. Food webs collapsed from the bottom up. Dinosaurs starved not instantly, but gradually. Civilization depends on complex, fragile systems. Electricity grids, global trade, just-in-time logistics. A prolonged reduction in sunlight would stress everything. But unlike dinosaurs, we could respond. Greenhouses, food reserves, adaptive agriculture, rapid coordination. Preparation transforms impact from extinction to crisis. And crisis is survivable. The subtle hope. Here's the quiet hope embedded in this entire series. We are not powerless. Dinosaurs were magnificent, but they were passive in the face of cosmic randomness. We are fragile, but we are active. We can detect, we can model, we can intervene. That changes the equation of survival. For the first time, life on Earth has a guardian species. Whether we fulfill that role is another matter. The ethical expansion. Protecting Earth from asteroids isn't just about humanity. It's about every species alive today. Millions of evolutionary lineages. Forests that took thousands of years to mature. Coral reefs centuries old. By preventing a catastrophic impact, we protect more than ourselves. We protect the quiet, the long middle, the continuity of life. In a strange way, defending Earth becomes a moral obligation to deep time. Here's the dinosaurs' unanswered question. If dinosaurs could ask one question across 66 million years, maybe it would be, could you see it coming? And we would have to answer, yes. That answer carries weight, because if we can see it coming and fail to act, then extinction would no longer be random. It would be negligence. That's a heavy inheritance. When the sky stays bright. But here's the more probable scenario. The sky does not darken tomorrow, or next year, or next century. Most of the time, space remains quiet. And in that quiet, civilization grows. Science advances. Risk mitigation improves. The longer we survive, the better we become at surviving. That positive feedback loop is powerful. It turns vulnerability into resilience over time. The real test. The real test is not reacting heroically at the last minute. It's investing patiently in prevention. It's funding telescopes before disaster looms. It's building systems before they're urgently needed. It's cooperating when the threat feels distant. Dinosaurs had no such option. We do. And that option defines our era, closing the horizon. Look up at the night sky. It feels peaceful. It feels eternal. But it's dynamic. Objects move. Trajectories intersect. History can shift in an instant. Yet for the first time in 4.5 billion years, a species is watching. If the sky darkens again, it won't be without warning. And that warning is the thin line separating us from the dinosaurs. They lived under the sky. We study it. They endured fate. We can shape it. And in that difference lies the future. If this series changed the way you look at the sky tonight, if it made Earth feel smaller and time feel deeper, before you leave, hit like. Subscribe if you want more explorations like this. And share this episode with someone who still believes civilization is permanent. Then leave a comment with one thought you'll carry with you after this journey. Because awareness only matters if it spreads. And survival has always been a collective act.